climate change, and I was like, I'm going to do it now. So close. Yes. It sounds terrible. So I was all excited. A couple logistics. It's the day after Earth Day. Earth Day always kind of floats around just a little bit. It's always one of these April 20th days, and So it was yesterday was the day. Lots of communities are having their Earth Day celebrations this coming weekend, as last weekend was Easter, and there was kind of too much overlap for them. So check out if there are events that are happening in your community over the next couple days. I know yesterday my husband pedal bike to work, and he was like, "It was Earth Day. I felt like riding my bike," and I was like, "I've created a monster," but I'm glad. This is cool, So think about those small actions; they add up. They make a difference. It was a long way for him to go. He was like, "I biked for like an hour and 45 minutes today total," and I was like, "Cool." So it wasn't so bad in the morning. He got to work pretty early. It was pretty gross when he came home, but we don't care. All right, so look around for things that you can do in your community. That relates a little bit to remind you that your homework 6, your proposal of what you would like to do next as a service learning opportunity, is due this evening at midnight. If you have questions or you need an extension, you need to use your something unexpected happened card, talking to me, telling me sooner rather than later is better. For those of you that have just recently participated in a service learning activity, homework 4 is also due today. A little kind of reflection on your experience. Several of you that have participated in our litter cleanup have already turned in your assignments. Awesome. The last logistical thing is that our last exam in class is next Tuesday during finals. So the study guide was online last Thursday, but I can give you a hard copy. Thank you. Yeah. I was looking at it this morning and I was like, talk about most of this stuff. Different than last week. Our exam next Tuesday starts at 9:45. It is earlier than class time, but it ends at 11:45. Like this time next week, you'll be mostly done with it. Okay. It will be the same format of test that we've had in the past. There'll be some multiple choice, there'll be some short answer. We have a 2-hour time block in which for you to complete your exam, but I'm going to be the same length as our previous exams. I'm not going to write it so that it's longer just because we have more time. It will again focus mostly on what is on the study guide and of course contain information that we talk about this week in class. And so if there's something on the study guide that we don't get to, of course, as always, it will not be on the exam. Any questions? You bring you and something to write with to the exam, and I will bring the exam. You will write on them. That will be it. We'll be done. All right. As you're looking at information, please don't hesitate to email if you have questions, of course. And again, looking at it a little bit sooner rather than later, it helps you out. Stress levels and then getting a good grade on the exam. All right, we need to talk about climate change consequences today and some possible solutions that are hanging out there. And many of the solutions to different things that we've talked about throughout the semester are also helpful when it comes to climate change, particularly when we've talked about alternatives to fossil fuels, and we've talked about all these different renewable energies. That is definitely a large part of the equation in terms of addressing climate change. But my hope at the beginning of class here is to refamiliarize yourself with some of these predictions that we have to give you a little bit of inspiration of why taking on change is worthwhile and why making these types of changes in both our everyday lives as well as in commercial industry, agriculture that we talked about all the time are equally as important. This is a picture that starts out the climate change, I believe the climate change chapter from our textbook, and although our lights today is fine. That's a little better. Yes, you can see the red areas are coastlines that are expected to be flooded with the predictions that we have for climate change in the coming, really kind of next 75 years, used to say century, but we're closing in on 2025. these predictions that we're going to look at today, most of them are for 2100. And so kind of the end of this century, looking at maybe past just at the end of our own lifetimes, definitely those lifetimes of our children and grandchildren. What will climate in the world look like?
So like the Caribbean's pretty much gone.
Yeah, the Caribbean's screwed.
So go now.
Go now. Good point. Go now. Visit the Great Barrier Reef now. If you're interested in any of those Indonesian islands, now's a good time to go to. Those are the places that are actually experiencing the most ravaging effects of climate change today in terms of sea level rise. And those are the places, again, where we're starting to see the first types of climate refugees. That people are having to leave their homes on these islands because there's no longer an economy and an agriculture, a fishing, ecotourism system to support them. They've lost the land on which they used to live, and they can't even go back to those places in order to fish or to make money in any other way because the land is gone. It's been taken by the ocean. And the reason, again, that the sea level is rising is because land-bound ice is melting, and the warmth that has happened thus far is being absorbed by the ocean, and the water molecules are expanding. We've already gotten 8 inches of sea level rise. And for some of these locations, that's enough to push them out of the habitable areas that are on the planet. Here in the United States, we're particularly, again, concerned about the Gulf Coast and the eastern seaboard. Again, places that traditionally have problems with flooding are expecting to see that flooding exacerbated. And I have linked for you last week a really nice article from NPR recently looking at what's happening in Miami in terms of the healthcare industry and some of the effects that they feel they're already seeing related to climate change, both in terms of flooding instances and severity of these natural disasters, then also problems that they're seeing related to heat waves in largely underprivileged and underserved portions of their community. And those types of effects are starting to have economic consequences for us today. We're starting to see people that need additional services because of climate change is exacerbating their existing conditions. It's making it more difficult for them to find services and to be able to exist on the fringes of current society. Okay. So we're going to talk about the impacts of climate change, and we're going to talk about some possible responses. This is a cartoon that ends this chapter on climate change in our textbook, and it reiterates something that I mentioned in the last class, that all these things that we're talking about in terms of shifting to and changing in our society in response to climate change, they all require a lot of change for us. And we'll talk, there's reasons why we're resistant to that. But none of these changes that we're asking to be made are designed to harm us. They're only in order to improve our quality of life. They're only designed to give us greater control and a greater connection to the world around us, to reduce inequalities and increase equity across all aspects, environmentally, socially, and economically, in our civilization around us. And there's very often not only skepticism today about the cause of climate change in terms of human-related causes, but then there's skepticism about who's going to bear the cost of responding to it. And it's very clear that it will be costly to respond, but I also heard this morning that we're spending somewhere around $9 billion a year responding to climate change anyways. So like if we want to reduce that expense, then we need to be willing to spend a little bit now so we can save a lot in the future. None of these changes are designed to take away rights or benefits or quality of life for those of us as we live here today. Okay, so let's look. All right. So our climate change predictions that I'm going to talk about today, looking again at these main areas where we identify that we have evidence of current climate change. So what do we think global warming is going to look like in the future? What will sea level rise look like in the future? What's going to happen to species in the future as they move and kind of migrate around? What will happen maybe to some of our weather patterns? This data is based upon the most recent IPCC report, which is AR5, that came out in 2014. They're working on the next version of this. IPCC is a large organization of international climate scientists and meteorologists that put together the best climate data that they have. They do the best climate modeling, and then they put out these predictions of what they think is going to happen in the next 50 to 75 years. They're working on the next one, and we're kind of getting close to seeing some of those first results of the next report. The most recent one was in 2014. Last year, the U.S. Association of about 300 climate scientists and meteorologists put out our 4th National Climate Assessment, which looked at specifically what's happening in the United States in terms of climate change today, and then predictions for the United States in the next 75 years. Most of that data, though, is based upon the scenarios for climate change that were laid out by the IPCC report. So lots of the stuff looks really similar, and there's a lot of overlap between these reports. Okay, so that's where all our figures and graphs and my data today is coming from, are one of these two places. As I mentioned, we're going to look at predictions for global warming. We're going to look at predictions for sea level rise. We're going to look at species distribution changes, precipitation patterns, and just a little bit of, again, this idea of the changing ocean acidification, changing pH of the world's oceans, because that's something that is a little bit harder for us to gauge what the overall impact is going to be, but it's likely to be one of the most significant impacts of climate change. Recognize too that we talk about climate change because it encompasses all these different things, not just global warming. Global warming is a part and parcel of climate change, but it is not the only thing that's going to be altered in terms of climate in the world and ecosystems around us. Here we have the U.S. projected increase in temperatures over the next century, looking kind of at 2050 in the top two images, and then 2100 in the bottom two. And there are different IPCC scenarios, there are 4 of them, about how climate and temperature and sea level will change. RCP 8.5 is the worst case scenario in terms of greenhouse gas emissions, where we actually increase greenhouse gas emissions, and as a result, we have more devastating impacts when it comes particularly to global warming and sea level rise. RCP 4.5 is the top 2 of the middle 2 scenarios, and that's kind of business as usual. If we continue producing the same amount of greenhouse gases as we are today, we don't do a lot to alter our greenhouse gas emissions, then we're committed to the scenarios that are put out by 4.5. If we're able to reduce greenhouse gas emissions, if we're able to actually store and remove carbon from the atmosphere, then we find ourselves in the 2.5, 1.5 scenario ranges. And we see still impacts, but they're less severe than if we increase greenhouse gas emissions, as you might imagine. Okay, so what do we see here in the United States? What are the scenarios by 2100 for average increase in temperature?
By 2050, you said?
I would say by 2100, the like
21.
lower 2. The lower.
Up to 8 degrees.
Yeah, in some places as many as 8 degrees warmer Fahrenheit. Again, that means that today, when it's going to get up to 75, it would get up to 83.
So in the summer when it feels like 105 with humidity, it'll be
Right.
like Arizona.
Yes, that means that those really
Moist.
warm days in summertime are going to be really hot. It also means that in wintertime, it's going to be much milder potentially. And that what used to be our coldest winter days, we aren't going to see anymore. And they might still be there, they might be very severe, but they're going to be less frequent than they have been in the past. Less snow days. Less snow days, yeah.
Not necessarily.
And again, there's pluses and minuses to that. And again, we're looking at averages. So we may still have the severe weather events where we get the blizzards and the snows, and these bomb cyclones are actually predicted to be a little bit more intense and frequent. But it'll be warmer in general overall. And again, that's good for agriculture. It means that the growing season increases. It means we can grow crops in our region that we couldn't grow before. We might be more productive in terms of agriculture, which is good and beneficial socially in terms of food production, biofuel production, economically in terms of income. But it means that there will be a shift, that things are going to change. Yeah. Caleb.
So the question that I had was I was doing a little bit of reading and stuff, and it was talking about how the only reason that we're breaking all these records and how warm it is because of our winters or because of our summers. Because when I was going through and looking at this data and stuff,
Yeah.
we actually had one of our coldest winters
We
in
did.
a long time this past
We
winter.
did, yeah. This last winter was quite cold in comparison to recent years. And again, whether or not that's weather or climate, we have to wait and see if that trend continues. And remember, it's not just the average that's moving, it's these extremes when we talk about climate change. And that may be feeding into it, that we get really cold stuff and we get this really hot stuff. It's the hot stuff that's been so prominent, definitely, in recent times. Nice job. All right, as we talk about these different things, I want you to consider the impacts and effects in a few different areas. And again, thinking of them in terms of the three pillars of sustainability. What are the environmental impacts on organisms and ecosystems around us? What are the economic impacts in terms of people having to shift where their income comes from? And then socially, what are the strains that dealing with climate change and altered ecosystems and ecosystem services, altered income, and economic activity puts then on our society in general. And as I mentioned, here in Ohio, we're pretty well positioned when it comes to climate change. Like, it's gonna get hot, we're gonna have different species around us, but it's not gonna become a barren desert. We're not gonna get flooded out by sea level rise. We might have more severe weather events, who knows? Okay, but we can build for that, and our current society is fairly resilient to types of change that we're gonna be experiencing. I think the big question comes into how are we going to be involved in the coastlines, particularly of the United States, and what types of input are we willing to put forward to help other communities deal with more severe effects of climate change? Okay. All right, so global warming. This is the data from the IPCC AR5 report, and looking at those 4 different scenarios in terms of what could happen in terms of global warming. We see again the red line, the worst case scenario, we might get up to 5.5 degrees Celsius in terms of warming. RPCC 4.5, which is what is thought to be a better case scenario in terms of what's more likely to happen in terms of stabilizing greenhouse gas emissions is the light blue line. Notice that even if we kind of stop greenhouse gas emissions in the dark blue line, we're committed with the amount of greenhouse gases that are in the atmosphere to somewhere between 1.5 and 2 degrees Celsius of warming, regardless of any type of change that we might see. Okay, like we have already introduced enough greenhouse gases to warm us another 1.5 to 2 degrees. Okay. The other thing to note is that there's big confidence intervals up in the box, and with their plots are off to the side of the line graph. There's still a lot of uncertainty about exactly where these ranges were going to land. Okay, it depends upon what we do, first and foremost, in terms of greenhouse gas emissions, largely carbon dioxide related. It also depends upon a lot of changes that are in the process of taking place in terms of climate, as to whether or not we go high on these types of changes or if we manage to hit the low end. What's been very interesting in that, compared to the early IPCC climate data, we've been able to narrow in these confidence intervals. So we have fairly high confidence in the terms of climate science that we're going to be somewhere in this 1.5 to 5.5 degrees Celsius temperature. Okay. All right, so what's most likely is, again, we're going to be somewhere between 1 and 6 degrees Celsius or 2 to 11 degrees Fahrenheit in terms of global average changes on the positive side by 2100. Again, it depends a lot upon the emissions scenario. The next few years of climate data and seeing which of these model lines we fall closest to is going to be really important, again, for nailing down which of these scenario tracks we're on and which of these models best matches the data and the observations of the changing climate and the changing world. And that's what's been most informative, I think, for climate scientists, is to have the last 10 years worth of climate data to use to proof their models, to verify which of these models actually is giving the accurate data for what is happening in the world around us. Again, depending upon emission scenario, we get warmer, we get warmer, or we get warmest. Okay. And again, places that are likely to change the most are at the poles, and that is where rapid change has already happened. That's where you have some of these positive feedback loops. Things like loss of sea ice and albedo means that there's more open water, more solar radiation that is absorbed, there's more heat in those locations, which means there's less sea ice, means you absorb more the next year. Those positive feedback loops cause the very increased warming that we have already seen in the Arctic and Antarctic, and that we anticipate to happen in the future. Again, other places are more or less resilient to these changes, depending upon their local geography, their local climatological patterns. Yeah.
Do you know what the average temperature is in the polar caps?
Not off the top of my head. I know several people who have spent months at the Arctic, but they say it's cold. I would say that over winter, it's below freezing, for months out of the year. That was my experience of their experiences.
Below freezing.
Yeah, so it's below 32 degrees Fahrenheit. It's below zero for at least a month out of the winter time. That's really, really cold. That time period where it's really, really cold is shortening. And even for some of the graduate students that I worked with at UBC that had gone a few times to the Arctic, their last visit there, they were like, it was a lot warmer and there was less ice and there were melt puddles everywhere. It was weird. Like, it was different.
Negative 34 Celsius to zero.
Not cold.
Do what?
It doesn't seem that cold. It just has to be below 32 degrees.
To freeze, right. So
The average January temperatures range from negative 34 degrees Celsius to 0 degrees Celsius. And the winter temperatures can drop below 50 degrees Celsius. In the summer, the heat wave is negative 10 Celsius to 10 degrees
10
Celsius.
degrees Celsius.
There you go. So pack your swimsuit.
That's like 50.
If it goes up 2 to 4 degrees, it won't be that big of a deal because it's still negative 34 degrees.
During parts of the year, but that, those days when it's above freezing are the important part for the Arctic. And those are the days then when you're gonna have melting and a loss of permafrost. And that's the basis of that ecosystem in terms of their land-based ecosystems. And that means that with the melting of the permafrost, you get these meltwater ponds, which are interesting aquatic environments, but it's different than what was there before. And the big concern in the Arctic with these warmer days and less cold days is that a bunch of this carbon that is stored in the peat bogs and the permafrost now is going to be open to decomposition by bacteria, and that they're going to release carbon into the atmosphere in the form of carbon dioxide, and that's going to exacerbate global warming. It's going to be a natural source of carbon dioxide that's in addition to everything that we've done previously. And so again, it's one of these positive feedback loops for climate change, that as you have a few more warm days, more carbon will be released, which causes it to be warmer, and you'll have a few more warm days. It adds up over time. Interesting ideas about how to prevent that. Interesting ideas about what will be the actual impact of this. We talk about worst case scenarios because I want you to be worried about them because I don't want us to get there. Okay? I would be really happy if the change is 1 degree Celsius and nothing really changes in the Arctic. I'd be like, yeah, okay. I'd be happy to say lots of this was wrong. Okay? I'd be really interested to know why it was wrong. Did that answer your question? Okay. All right. For humans, the increase in global warming is something, again, that's interesting to think about, and that most of our concern with global warming has to do with heat waves and the resulting heat exhaustion and heat stroke that can affect largely urban populations, again. In lots of urban areas today in the world, places like Seattle even, air conditioning is not a common phenomenon in homes. And so again, in places in Europe, places like Paris, and many of the cities in Germany, and throughout France, where we have large urban populations, their infrastructure is old and it certainly isn't modern when it comes to air conditioning. They have heating infrastructure, but air conditioning is much more difficult. And so this means that for vulnerable populations, warmer days increases the chances of having medical complications. So for very young and elderly, for people who are already experiencing problems in respiratory illness or cardiac illness, the addition of hot body temperature can send them in a spiral of health problems. This means that as we have more heat waves, as we have extended heat waves in some of these locations, we expect to see more people in distress, and we expect to see more deaths. And we're already starting to see this again in some of these big urban centers in Europe in the past few years where they've had these types of heat waves, and they've had 200, 350 people die. And it's like, you don't have air conditioning? And it's like, yeah, I don't have air conditioning. Historically, it hasn't been that hot to need air conditioning in these locations. And so this new change means that we have to deal with that. This particular diagram flowchart of potential impacts of global climate change on human health comes from the Tennessee Department of Health, which I thought was
Thank you,
really
Tennessee.
interesting. And I was like, oh, Tennessee is kind of thinking about this. And this is something that I want us to recognize, that many institutions around us are thinking about how to deal with climate change, or trying to predict the types of service systems that they're going to need to have in place in order to deal with heat waves. And to have people in neighborhoods that are going to go to those houses that don't have air conditioning, that are going to check on the elderly, that are going to check on newborns and families with toddlers to make sure that they are cool enough that they have somewhere to go during the day. One of the crazy things I heard, again, on a 99% Invisible podcast recently, was that after the Hurricane Sandy in the Massachusetts, New Jersey, New York region, the communities are trying to build these places that would be like climate change resiliency centers that people could go to, that would have air conditioning, that would have reliable internet service, that could connect you with new jobs, that could connect you with emergency service agencies, that could give you housing or food when you needed it. And they were like, we're going to build this place where everybody in the community can come, and when it's not a national, emergency situation, you could come there and you could have, childcare classes, and you could have bowling leagues for elderly, and you could have gymnasiums for adolescents, and, game consoles where kids could play games together and read books and do all these crazy things. And he's like, we're going to build these all over the Eastern Seaboard. And the guy was like, we already have those.
Big Brother, Big Sisters Club.
They're called libraries. Okay. Like a lot of these services that we associate with our communities as the basis of our community centers, like Big Brother, Big Sister centers, like YMCAs, like libraries and community centers, we already have them. Okay, we need to continue to fund them in order to deal with these types of climate change problems. Yeah.
And I just thought of when we were talking about no air conditioning and like checking on the elderly. I mean, even here in the summers when there's a heat wave, they have cooling centers that
Right,
they set up in the
exactly.
city for the homeless.
Right,
and the
exactly.
elderly.
Yeah, and they work really well. Again, like the parks down on the waterfront, right? They have all these water features, and like the kids go crazy, and it's a really nice place to cool off. There are all kinds of people that rely upon those types of infrastructure services as their main way to deal with these types of events. Yeah. Okay.
The only comment I have is the whole thing on libraries is, we don't have libraries.
Yeah,
It's
we
called a
do.
Media center.
So yeah,
Because
think
there
about it,
aren't books in there.
because you can get your books online.
I went to the library up there and they have
Oh, down the street from a huge library
a
that
very
has kids' camps and
small,
books.
I'm trying to think of it's right by the Milford Elementary.
Live in the wrong
School.
county.
What school is that?
So, and again, our
They have a 3D printer with their own books.
So yeah, isn't that interesting? The thing that is most accessible to us is a hard printed book, and yet they're going away. And again, this idea of what is necessary and what is new and cool and interesting, it doesn't always jive. And we do need to be responsible about how we're spending our funding when it comes to these types of media centers and locations, and training librarians to be able to deal with everybody that walks in the door. Willow?
The Williamsburg Library is really just a place. Like they call it the library, but they just hold like town meetings.
Really?
And they hold community events there.
Right, and again, that's cool, but it's not what you go to the library for. Like, certainly, like, I love libraries. I love books.
My
Like,
kids
I
have to
wanna
be
go to the
quiet
library
when
and
they're-
see lots of books and be able to, like, pet them and smell them, that old monkey smell, like.
Yeah.
And the fact that there's all these movies I can get from the library, like, kind of bugs me a lot. I didn't come here to watch Die Hard 3, although I'm taking it from me.
I think they should make gymnasiums like big libraries. I think it's ridiculous that there's no such thing as a public gymnasium.
There is.
So, but again, it depends where you live, right? And outdoor parks and green spaces used to serve that type of gymnasium aspect, and we have moved away from them. And again, our expectation of what we want from these public spaces is constantly changing and evolving. Maybe for the good, maybe not. Yeah. Morgan.
Everyone else is talking about how their libraries change. We have a library that's like really close in town. Last time I walked in there, it was the same as when I walked in there when I was in preschool.
Right, yeah.
It's never changed. It's kinda
Right.
boring.
And so that is, again, is an aspect of this, like some places have changed too much and some places have not changed enough. And that's a sign of the inequality of the differences in values and opinions and funding that we see even in our kind of local area. And, you know, that's something that maybe you're fine with and maybe you're concerned about, maybe you would like to see change. Okay, one of the things from global warming, of course, is gonna affect human health, exacerbates current conditions. Remember that most of our worst air pollution is also associated with high temperatures and high humidity. That's what helps to form smog. That's what forms those inversion layers that keeps air pollution next to communities. And so the problems from air pollution will be exacerbated with global warming. It also affects agriculture. And in some places it will help agriculture. And in lots of our major places of agriculture today, we're gonna see that crop productivity is expected to go down with climate change. The diagram is showing you the movement and changes in plant hardiness zones that has already happened in the United States. So you're gonna go to the nursery and it's like, you're supposed to plant this in zone 5. And then if it's not, a plant that's supposed to grow here, and you're like, oh, it's gonna need more water than I expected, or it's gonna be too hot here this summer, maybe you don't buy it, right? We have already seen a shift in where these plant hardiness zones are. Here in Ohio, we used to be in 1995 6, and now we're pretty much only 6, and we're starting to see the upcreep of zone 7 types of plants that can grow here comfortably, all the way up through Kentucky and into our region in southwestern Ohio.
Why is,
Hang on, Willow.
I was just asked, so since the winters are getting as cold, does that mean that the bug, like, say
Yes.
bugs or
Mhm.
anything, so you think like disease, like different diseases are gonna
Yes.
come up?
Yep, that's one of the big concerns with climate change and vector-borne illnesses, so illnesses that are carried by bugs, both for crops, which is part of this reduction in crop productivity, but also for human health, is that as these organisms push into latitudes where they haven't been before, we're really anticipating a spread of some diseases, particularly of malaria, which is a tropical illness, and now we're starting to see it crop up in more temperate latitudes. And so, again, malaria hasn't been a large problem here in the United States, but it definitely is expected to be the Texas and Florida and Louisiana in the future, as the mosquitoes that carry it are now able to exist here in the United States and haven't been there before. Traditionally, those cold winters kill off a bunch of these bugs and delays their emergence in spring, summertime, so we have less exposure to them in summertime. As it's warmer, they emerge earlier, fewer of them die out over wintertime, means we have problems with invasive species like the emerald ash borer. I think it's the painted lanternfly that's gonna be problematic for our region this coming summer that you should be on the outlook for. I have to check the exact name of that sucker.
what does it do?
Does it wear a name tag?
I think it eats conifer trees. I think it eats evergreen trees.
Oh. Those have a
Let
hard
me
time
check.
surviving anyway.
Let me look.
Like kills them or eats them?
Well, it eats them and then they die because you ate the living tissue. The bugs eat the living tissue of their trees. Let me look. Let me check. So we're really concerned about that. And again, the idea that we're already encountering ticks in our environment in March, April means that there's a greater incidence and chance to catch tick-borne diseases, both Lyme disease as well as a variety of other little parasites. So yeah, those vector-borne illnesses in the movement of invasive species into regions because it's warmer and there's less cold. It's problematic. I'm really excited to go camping this summer because we had a hard winter and there should be less bugs. Okay.
So that's what I was wondering, is really when you look at it, it's not so much that it's warmer, longer, because bugs still survive in the fall and spring, like they don't die off when it's 70, 60 degrees.
No, yeah.
So when I'm looking at this stuff, they say it's getting warmer, but really all they're saying is it's warmer when it's supposed to be cooler. We're still having really cold winters, at least in Ohio.
We have this last year, and that year was different than the 3 or 4 before it, when we had milder
You
winters.
have
It's my understanding, I haven't lived here long enough to promise you with that stuff.
what was it, 2.5 years ago, we had the hardest winter ever in Ohio,
Okay.
because we had negative 6 for like a week.
Sweet. That's like Minnesota weather.
But it's just, I don't understand the flood thing, because as long as we're still having dark winters, we're still all gonna die. It's gonna be warmer. I mean,
But it's not just that you have a period of cold, it's that you have an extended period of cold. So you may have had one week where it was 6 all week, but then the next week it was in the 30s. Okay? And then the week after that, it was still in the 30s. And it didn't get, super, super cold any other time during the year. That little bit then kills a whole bunch of stuff, but it's not for week after week after week to really push down the population for those organisms that aren't adapted to that short period of cold. Still not buying it.
But it's just, the flood thing is hard for me because we haven't really had warmer winters. They've been pretty much the same. We've had warmer summers for sure.
Yes.
Our
Yeah.
summers are definitely warmer, but our winters are still just as cold as they were.
But they're shorter, right? Like they start later and they end earlier in the year.
Like if you have a dog,
What?
think about if you had a dog and like your dog got really bad fleas, like you're gonna get fleas earlier in the season.
Yeah.
Like that's kind of, like they're gonna get fleas earlier and they're gonna have fleas longer than let's say what previous.
Maybe I'm too sheltered, but I've never had any problems with any kinds of bugs.
Maybe your
Glad
parents
for
paid
it.
for like the exterminator stuff.
I'm glad.
Well, this is just one state too.
Good.
I lived in Tennessee and the winters are like nothing anymore because they used to be colder, but they're not at all anymore. They get gradually get warmer.
I think that's important, not just looking at this local area, but globally.
Like I said, maybe we're lucky. Okay, one thing I want you to notice is that wheat production and soybean production in the United States is projected to go down as our main agricultural zone becomes too warm for these types of plants. So again, Oklahoma, Nebraska, Texas, the Dakotas, Iowa, places where we traditionally grow these types of grains, that plant zone is moving and changing. The other big concern is that changing precipitation rates and as these locations where we have large urban centers today dry out, then we're looking at additional freshwater resources shortages. So we're looking at another billion people that might be facing freshwater scarcity due to climate change, changing precipitation patterns and causing places to be warmer and need more water in the first place. But things like gross domestic products are changing. Who we trade, import and export kind of ratios is going to change as different countries become resource rich that have been resource dependent. Places that were resource rich now need to import lots of things. And that changes our relationship with our neighboring countries. And that's predicted to lead to some conflict. And we very clearly today don't have an international body that can deal well with these types of conflict. So that's concerning. Yeah.
Why is there a decrease in, like when I look at the map, outside of the black, we haven't lost anything, it's just moved up.
Good. We haven't lost anything, but it has changed where it occurs. And so farmers, for instance, that are in Kansas are growing different strains and varieties of wheat and corn and soybean than they have been in the past because the temperature is warmer and they're trying to avoid the need for irrigation. And
Why
so
do they switch?
why did they switch?
Why don't they switch?
They do, and they have here in the United States. That's what genetically
why.
modified crops are designed to help us with.
That's why the
That's why I'm
agri-
confused about this,
changing, the
because
next
they're
one.
moving everything up.
Yeah.
They're just being like, good farmers are gonna know that the zone changed.
Right.
So how are we down 75% wheat unless?
We're gonna stop growing wheat in favor of other types of crops. Okay, like
Is this in the
eventually,
future?
yes, yeah, like we're looking at 2100 range with these predictions.
I can't tell with these charts.
That's okay. Okay, the changes that we've seen here are 1990 to 2006,
Okay.
and these projections are for what's gonna happen in 2075, 20.
I thought this was from 1990.
No, we're still okay on wheat production.
I was like.
We have an excess of corn and wheat and soybeans that we grow in the US. We're net exporters. Okay, all right, so global warming impacts. Remember, it will affect energy consumption and economics, that as people need access to more air conditioning in summertime, then we have an increased load on our electrical grid. And that's something we've touched on a few times during the semester is how poor our electrical grid infrastructure is, how inefficient it is in transferring electricity, which causes us problems in the first place. But then getting electricity where it's needed in a timely fashion is going to shift. That places that use less electricity are now going to have a greater need for it, particularly with increasing human populations. So we need to spend money in order to upgrade our electrical grid and be able to deal with these changes. It also means in ecotourism, recreational opportunity things that the places where we used to be able to go snowboarding and skiing in the wintertime are going to be different places than where they are today, unless we invest in, again, energy inefficient things like the artificial places where there used to be water reservoirs that we utilize for boating or fishing might dry up. Their location might change. The seasonality of when we can use those resources might change. And for some communities, that is the basis of their economy, and that can be very locally devastating when things change. When the national forest, grows away from you, and that's what you had based your town on, where all these bed and breakfasts is, then it can be very impactful. That makes sense, everybody? Probably not, mostly because lots of our national parks and national forests are already ringed by development. And so although the southern border might push up and become a grassland ecosystem or a desert ecosystem, they're not going to be able to move northward and migrate in terms of the forest ecosystem. Okay. Again, related to what we were talking about in the Arctic, we're concerned about methane release as the permafrost melts and we have decomposition of the carbon that is stored there. As the Arctic seafloor changes, again, its biodiversity and microbial composition, we expect it to, again, release methane and carbon dioxide in these bubbles that will add to our greenhouse gas emissions. As it gets warmer in the tropics, again, this type of decomposition will ramp up. And our increased livestock production is a big source of methane, as we talked about, and that as our changing diet patterns are altered, we're going to have more of these kind of natural inputs of greenhouse gas emissions, which could potentially exacerbate our global warming scenario. That kind of moves us from one of those scenarios to another. And the last one here, of course, is that we expect our ecosystems to change. As we just talked about, our forests are going to migrate northward here in the northern hemisphere. Our grasslands are going to be moving northward. The places where we traditionally grow crops, the places where we traditionally harvest lumber, the places that and ecosystems that buffer our shorelines are going to be changing. And the climate is changing faster than these types of organisms grow, reproduce, and can adapt to the changing selective pressures around that. And that means that we're going to have reduced ecosystem services. There will be less nutrient cycling, or will be in an altered fashion, which affects our fertilizer use. We might have more shoreline erosion as we lose some of those sand dune grasses and mangrove swamps that hold sand and ecosystems in place. We're going to lose some of our pollution filtration, again, as organisms and communities are in the process of transitioning. And those are things, again, that we take for granted. And something that I have to mention when we talk about ocean acidification, too, is that it's not that the world is going to become barren because of climate change. It's just going to be different. There are species that are going to do very well with climate change and species that are not. And if we value those species that are not going to do well with climate change, then we need to have a replacement in line for them. We need to be genetically modifying crops. We need to be moving and migrating organisms in a purposeful fashion so their populations can remain viable for us to use. Whether that's for an actual producing a product for us purpose or because we find them aesthetically pleasing and charismatic, our ecosystems are going to change and we need to be prepared to deal with the consequences of that change. The world's going to end. Almost. It's going to change. And again, we put out these doomsday scenarios. It's going to get really hot. Sea level's going to rise. Everybody's going to need to move. We're going to need to eat different things. That's probably true, but we're probably still going to make it as species. Yeah.
So things start to die. So for instance, the emerald ash forest is doing really well, so obviously all the ash trees are going to crap. If we were to save those seeds or whatever and wait until, I mean, eventually there are going to be no more ash trees and the ash forest will die, right?
Hope, yeah. Long term, certainly.
Is there any way that they, like,
So we have big seed banks. There are at least 15 large seed banks around the world that store seeds from all different types of plants, both very important crops of all different cultural varieties, heritage varieties, we have to call them, and native organisms. And so there are lots of ash tree seeds, stored in a variety of different locations. The biggest one of these is in Greenland, I think, built down into the permafrost, so they
really
can
cool.
reduce refrigeration costs. And they've had problems with flooding in lack of changing temperatures already. We can replant from these, and there's a lot of hope in those types of captive populations, of banked populations. The concern is that how long will it be until we can restart the ecosystem, and how bad is it going to get before then? Will there be a human civilization left to go into the seed bank and start replanting?
how long would it take conceivably? You know, think about after all the ash trees are gone,
Yeah,
the ash forest is going to have nothing to survive on.
right. Assuming that it goes extinct and you can prove that it was extinct, then you could really restart planting ash trees with some confidence that they would make it, and that they wouldn't just immediately be predated upon by a variety of different insects. It's hard to say. You could cause the ash trees to go extinct this year. You might be looking at a decade or 15 years before you might feel confident that the ash borer was gone.
That is, I mean, obviously there are still some trees that are going to exist after
Right.
you say something's extinct. But if the only thing they have is ash trees, how could they live for 15 years without any ash trees?
So you have a larvae and eggs that are stored in the ecosystem, and they'll continue to pop out at a variety of times. Most of them will come out the next year, in the next 2 years, but you'll still have some that are in just the perfect little storage conditions that are just waiting around. And it just takes a couple, male and female, to cause a problem. Perhaps, in the intervening time period, we can genetically modify ash trees to be resistant to emerald ash tree forest. And that's worthwhile research too. Okay, in terms of sea level rise, again, we've talked about this before in class. We're looking at somewhere between 40 and 60 centimeters, or 1.3 to 2 feet of sea level rise by 2100. The worst case scenario in that RCP 8.5 is 7 feet of sea level rise, and that's like all Greenland ice sheets and lots of Antarctica melt as well. I don't think we're headed for 7 feet of sea level rise. And it certainly won't happen overnight in a future tsunami wave. But we are going to experience sea level rise. And for those places that already have problems with flooding, this makes an even larger problem. It means that when we do have hurricanes and cyclones that come to shore, they will be moving farther inland with their flooding, and their flooding has the potential to be more severe than it has been in the past. All right, where, are we looking in the United States of places that would be impacted by sea level rise? Again, worst case scenario, the bottom, we're talking about 6 feet of sea level rise in Texas, Louisiana, big parts of the northeastern coast of the United States. I mean, that's frightening. And I think that's what many of the communities along the eastern seaboard are very concerned about, these types of projections. What they're more likely to encounter is more of that kind of foot of rise of sea level. Yeah.
What are those random dots?
That is looking at Hawaii. This part is Hawaii, and these are our other little territories that we have in the Pacific. We have these. We collected all these refueling stations during World War II, where we have little bits of land in the South Pacific.
So are they still refueling stations?
Yes, they are.
So they have to remove.
We have to move them, yeah, or we need to build up the land and build a seawall to protect those locations if we still want to use them as bases. That's why we have a lot of friction with China in the South China Sea, is because we're starting to butt into each other in terms of what we claim as territory.
They could make it into Atlantis.
Wouldn't that be cool? I would totally live in a bubble city underwater. Again, like Mars, bubble city underwater. How about either place?
Whichever one happens first.
Yeah, probably bubble city. All right. The next thing that we expect to change with climate change is, as we've been talking about, species distributions. Organisms will move into new geographic areas. They're going to move northward in our hemisphere, in the northern hemisphere, or they're going to move higher in elevation. They're going to go up mountainsides. This type of migration really favors large, warm-blooded, mobile organisms, okay? Grizzly bears, coyotes, birds, of all kinds of shapes and sizes. It's really bad for plants. It's really bad for small invertebrates. I mean, think about how far can a worm migrate in a year? Do they even know they gotta migrate? Again, migratory species have built-in ability for transit and mobility. Other organisms are very geographically restricted. And it's those types of organisms that are endemic, that already have small populations, that already live in the poles or at the tops of mountains, that are gonna have a much harder time adapting to climate change. Yeah.
So, since all these animals are migrating, so I know like zoos create ecosystems
Yeah.
for their species,
Yeah.
but will they have to adjust for species they have?
Oh, yes, yes. And it becomes much more expensive to run things like an Arctic ecosystem in some place like Cincinnati as it gets warmer and they have a lot, and they have hotter hot days. And they have to restrict sometimes when animals can be on exhibit kind of out in our climate in order to protect them and what their particular kind of extremes are in our go-to. These types of migrations will happen, and some species, as we talked about, are already moving, like the fish species in the North Atlantic and the bird species here in the United States. Definitely organisms like our big grazers and our big cats and our birds and our butterflies, they can move at the rate at which they need to match our different scenarios for climate change. But organisms like snails and plant species and fungi and small rodents and small bugs that don't fly, again, they're like spiders, okay, are bugs, but they don't think, don't worry about taxonomy today. They're gonna have a harder time migrating. This means that as organisms are moving and shifting, we're gonna see and experience food web disruptions, that organisms that were predators are gonna be predating in new areas and influencing different populations. New competitors are going to arrive in ecosystems. There's gonna be holes in the ecosystems in which they feed in terms of food webs. This leads to loss of ecosystem services until new species emerge, until the changes are made. It also, as we talked about, will lead to new zoonoses, animal-borne, vector-borne diseases as these organisms migrate into new locations. That's a concern for human health, also for the health of our organisms in the ecosystem around us. This type of climate change may lead to the extinction of up to 50% of species that we currently have identified in terms of plants and animals on the planet. That's the really extreme worst case scenario, is that we lose 50% of species by 2021. Have you guys watched Isle of Dogs?
Yeah.
Dude, that's awesome. We watched it this weekend and I was like, of course the dog has to sleep. It's like a Wes Anderson movie where it's like, what if he could make every single shot he wanted to because he didn't have to work with actors that were imperfect. Okay, all right. What have we already seen in terms of changes? We're looking at the lodgepole pine in migration, as well as damage from their invasive beetle species, mountain pine beetle, in the western United States. Here on the left side, we're looking at the distribution of the lodgepole pine in 1967 to 1990, in the green areas of places where it occurs. And I think its expected projection by 2040 is what is the green areas on the side. The browning that you see in the forest in this picture is largely due to the mountain pine bark beetle again, eating the living outer tissue of the trees, and then they die in the next few years. This means that this is the foundation of lots of the timber industry in the western United States, as well as in Canada. And so if we want the lodgepole pine to still be around as a successful species, then we have to help it migrate northward. We have to think about our timber harvesting and forestry practices to allow for some loss, as well as in building up populations in the future. And so foresters in Canada are being very forward thinking, and they're planting species of redwood conifers that currently live in California in British Columbia in anticipation of climate change. That the species that they need to grow and start growing now so that they have a harvest in 2040, 2050 are species that currently live in a much more southern latitude than they have now. So that's the climate they're gonna have. Okay, in terms of precipitation changes, definitely we anticipate that our weather will shift a bit. We should get more intense precipitation events. We may see changing frequency of things like hurricanes and cyclones, although that's been the prediction for the last several years, we have not seen an increased frequency of hurricanes or cyclones in the Gulf or in the Pacific and Indian Oceans. We've had more severe incidences, but we haven't had more hurricanes than we have had in the past. Our prediction for changes here in the United States are that the northern portion of the United States will be a bit wetter, but the southern United States is going to get quite a bit drier. And all those warm temperatures in the southern United States cause a lot of evaporation. Where that precipitation then falls is in the northern and eastern United States, rather than in the place where the evaporation is. Again, Ohio looks pretty good in terms of temperature and precipitation changes.
I mean, we're pretty wet.
We're already pretty
We've
good.
always been.
We're in a good spot.
I was wondering,
That's always.
it's 80, the next day is 40.
Variety is the spice of life.
Yeah, it's like, I want to wear my tank tops, but I just can't. My kids are like, can you wear shorts and a t-shirt today? And I'm like, yes, but you have to
With
wear
a
your hoodie.
sweatshirt.
And they're like, no, I'm not wearing it. And then we get outside and they're like, I'm cold. I told you. All right, again, this is expected to affect agricultural productivity as precipitation patterns change. Kind of the double effect of, what determines climate and what vegetation grows is precipitation and temperature. So as temperature changes, so will precipitation patterns. Again, places that are going to be affected most are sub-Saharan Africa, India, Australia, southern portions of the United States. Other places will benefit in Russia, the steppes of China, Canada. Those are places where it's too cold now to grow lots of crops that we utilize in human nutrition. They're going to have the great climate that the places in more tropical latitudes have too. Okay. Ocean acidification. Again, we talked a little bit about what is ocean acidification. It's a change in pH of ocean water around us. It's caused by increasing CO2 in the atmosphere. It interacts with water molecules to produce hydrogen ions. And this is the chemistry of that for you. I'm not going to test you on the chemistry, but I wanted to show you the equations to remind you that this interaction takes place in the absence of global warming, in the absence of sea level rise, in the absence of changes in species distribution. Ocean acidification will happen simply because of increasing CO2 in the atmosphere. And that is happening, it has happened, and is projected to continue for the foreseeable future. And so we anticipate that ocean acidification will continue, and the buildup of these hydrogen ions has real consequences for organisms in aquatic environments, particularly marine environments. Okay, it has a direct impact on shell and skeleton formation. It causes organisms that utilize calcium carbonate in their shells to have a harder time building their shells. Their shells tend to be more fragile, and they have to spend more energy on building and maintaining their shells, and so they grow slower, and they don't grow to the same size that they did in the past. This affects things like oyster and mussel production. It's been shown to affect crabs as well. It makes lobsters bigger. I like lobsters. It does. They like it. There's something about it. It helps seagrass grow. It enhances kelp forest productivity. So again, there are winners in terms of ocean acidification and climate change, just as there are species that are going to be really poorly able to adapt as well. Where we expect this to go in the future in terms of ocean acidification, again, depends upon the scenario of what happens in terms of greenhouse gas emissions. And again, in the case of ocean acidification, it's not just all greenhouse gases, it has to do with carbon dioxide emissions in particular. Okay. In terms of ocean acidification, currently today it's about 8.1 across most of the world's oceans. There is local variability with particular ocean currents. Again, depending upon the scenario, we expect it to go to somewhere between 8.0 and 7.8 in terms of ocean pH. And you're like, that doesn't seem like a big change. Remember that pH is a logarithmic scale, and so a change down to 7.8 would mean about 150% increase in hydrogen ion concentrations in the world's surface ocean in comparison to what we have today. And that would be very detrimental for lots of these base of the food chain, fishing-related organisms.
So what's more, well, I guess either way it's acidic, but that's whether you go basic or acidic, it does the same thing.
It changes, right? And it's
Do you prefer basic over acidic?
the organisms in terms of hydrogen ion balance and calcium carbonate dissolution would prefer to be 8.1, 8.2. That's the environment that we have now and that we have had in the past, like 200 million years. This represents a big change for them, and this is such a fine balance that it will likely push lots of these organisms kind of over the edge in terms of extinction, in addition to rising sea level and warming sea ocean temperatures.
So what's the problem with adding things to make it stay basic? Like,
Good,
we're
so
already adding this other stuff, so why
Right,
can't we just
yeah.
dump a whole crap load of bait, like.
Becky,
just
so
dump
honestly,
baby
like,
stuff in there?
so they've done these experiments on the Great Barrier Reef where they take a section of the reef and they literally dump in like tums, like ground up tums, like rolates. And like, it does, it helps. It raises pH, it combats the acidification, sucks up the hydrogen ions. Can we do that in the whole ocean?
But are there any negative effects?
Not that they saw over that time period. It was a big addition, it was a big change for the ecosystem. It definitely affected water quality, like light penetration, which is also important in these kinds of coral reef places where we anticipate the most amount of change. But it does help with that. I would say that the long-term problem is that you have to do it constantly. You have to do it on an oceanic scale. It doesn't stop the problem of ocean acidification. It just allows you to adapt to the impacts.
Well, because if you did, what are they expecting it to change to? Like you said, 7 point,
To 8.0 to 7.8, to go down to 10 to 0.3 of another pH.
so. And that's total, by 2100 it goes
Yeah.
down 0.1.
Right, and it's not, but again, remember, we have all these projections about 2100, but it's not like it stops. And a 0.1 change in pH represents a 10 to 30% change in hydrogen ion concentration, which is kind of bigger than the unit.
My brain's all over the place. I'm just thinking like when we go, if it's at 8.1 and it tries to go down, but we're predicting that the carbon levels are going to level off, which means that the ocean carbon levels are also level off.
Right,
Which means eventually it's going to stop.
it will
becoming
stop,
more
right, it'll
acidic.
come into equilibrium. Where it lands though, is somewhere in this 8.0 to 7.0 range.
So that's, if obviously, you have to do it on an oceanic scale, but if we
Yeah.
found a way to dump all this stuff in there, we don't have to worry about doing it again because it would equal it out and it's not going to gain any more carbon.
Because we've
it's
stopped,
already
right?
leveled off.
Right, good. So if we can stop carbon dioxide emissions, we can set ourselves in and set ourselves up for being able to deal with these consequences.
It's like, no, to stop, we just have to, if we stay the same, it levels off in the atmosphere, which levels off in the ocean.
Right, exactly, yeah. But we have shown no inclination to do that.
Yeah, it's a level off.
Okay, a lot of our solutions are based on leveling off, starting to deal with greenhouse gas emissions, and largely the globe has shown no real movement towards success. A few nations have made big changes, but the nations that produce the most greenhouse gases have not. Okay, all right. This is like impacts on humans of ocean acidification. Lost fishery money, we have to spend more energy to get less food. We're looking at the cost of the Pacific Islands and territories in the United States due to ocean acidification and the loss of coral reef habitat. We're looking at the year of onset of which this becomes really problematic, and kind of how much area of their coral reef is expected to be bleached, so kind of completely lost by 2050. And that's problematic for these places that depend upon the coral reef as the foundation of their economy, whether it's fishing or ecotourism. And so the loss of the coral reef ecosystem is probably the most concerning when it comes to ocean acidification. And then along with that, we're starting to see changes in the abundance and species richness and distribution of lots of different ocean phytoplankton species, which again is the base of the marine food web and open ocean ecosystems. And that's again very concerning when it comes to fisheries for humans, and then in terms of biodiversity for other types of organisms as well. I want to spend the rest of the class talking about solutions. Look at the slides for terrible things. We talked about lots of terrible things. Okay, so I'm going to ask you to find your partner from last Thursday, and you can come up and I will give you your worksheet. And on the back of your worksheet, I want you to list for me 3 or 4 solutions to climate change, or one of these aspects of climate change that we're predicting for the future. Okay.
The handwriting the same.
You want me to work on your phone, or you can do it in another group chat? Okay. On the back of your worksheet, I want you to list for me 3 or 4 solutions that you can think of for climate change.
Pink.
It looks bad. Okay. But there's hope. We can change the future. So what should we do? What are our options when it comes to climate change?
Invest in alternative energy sources. Yeah.
We should all invest it in this sites, combating the already present changes.
Mm-hmm.
I mean, yes, hypothetically, but realistically.
Or like, think about like, how do we go about stopping polluting? What are some like concrete actions that would change greenhouse gas emissions?
I mean,
But
I
there's
think
natural greenhouse gas.
those are all big companies, but I think the biggest change comes from like
Right.
individual choice, like promoting like
So are there ways that we can,
personal
what do we need to do to stop
responsibility
emissions? And then
for like
are there ways that we
consumers.
can?
Like,
Bring back. Companies to try and have more green approach to
Sure.
Right,
You say so,
like
but-
being more responsible and like making conscious choices about where food or energy, like all those things come from.
That won't be as bad as just driving around a Forston Park, but it's not as bad as carbon dioxide coming out of our cars.
It isn't.
I think it's pretty concrete.
Like being educated, like where. What the actual
Drive
cost
things
is.
down.
You know, we talked about the actual cost.
shit.
And then I think like holding industry accountable and being willing to sacrifice.
Your concrete idea on concrete.
Yeah, to sacrifice, familiarity. Because I think that's really what it is. It's not even so much as a sacrifice, like being willing to sacrifice familiarity for the good of the team. I think that's really, it's just more comfortable. Right.
It will. It'll save you later.
Yeah, oh, so you have to spend more money for that, well, maybe you have less money to spend on things that
Somehow
are
it's
actual
fine.
pollution, like that. It's like the consumer is responsible.
And then you hear the bad.
Right, but
Okay,
And when it's not.
all right, what are some concrete solutions that might help us address climate change?
yeah.
Go ahead, Willow.
Stop releasing greenhouse gases.
Okay, we're gonna stop. Okay, Cassidy, you had your hand up.
Temporary restrictions on the chemicals that come from these levels.
Okay, what else? Caleb.
So I have a two for it goes, they go together. So first, if we reduce the use of fossil fuels for energy and start using more, renewable sources of energy. And then we switch over to electric cars. Not only are we reducing the carbon footprint for the cars, but also for electricity. Because
Good.
if you have an electric car, but your electricity is coming from carbon, you're doing the same thing you would have done anyway. So if we switch both of those, that's when we can actually make a difference.
Good deal. Elena?
A change in diet and agricultural practices to reduce methane.
Willow?
We need to educate people.
Education.
Why does education help?
And then more people know about the problem, there's gonna be more people have opinions about it, and I feel like more things get accomplished.
I wanna like add to that, I think like a lot of times we think of big picture, like the corporate, big picture kind of solution, but I think the real change comes from like small things in cultural mindset changes. So like if you're educated and you make mindful choices, like educated choices, knowing where your food's coming from, knowing where your energy is coming from, and demanding accountability for those things, that's where real change comes from.
Yeah, I feel like if you have an understanding of the science of climate change or pollution, or of renewable versus non-renewable energy, then you have at your fingertips the information to make a mindful decision. And whatever your decision is, if you're like, nope, I'm gonna continue the way I'm going, at least you have made such a decision. You know, even if you do something that I personally might disagree with, at least you're basing it upon good science and solid information. And in that sense, then I think that you're more likely to make a respectful decision. But even if you don't, at least you have like a real reason.
We just know you're a jerk.
I was gonna say, so there are multiple corporations that could help, reduce a lot of this stuff. So if we do incentives such as, for garbage companies to contain the methane that's produced from their trash.
Yeah.
While also, talking about like the cows and even, obviously the electric companies and stuff, but if they get some sort of incentive to reduce that or to change to something else, that could be a huge way to reduce a lot of carbon dioxide.
There are a few places where, like with ozone loss, CO2 production that caused it, there are a few targeted changes that can be made, the concrete industry, the asphalt industry, our refrigeration chemicals, our livestock production practices, where we can make big consequential changes to global warming. There's a few players that need to make those changes. But it's obvious they have to be incentivized to do so. And that pressure for corporations comes from monetary or regulatory standards, frameworks.
But one thing nobody wants to do, if we want to do that, we got to pay more taxes.
Good. So that's another thing to recognize is that if we're going to let money speak like that, money has to come from somewhere. Okay. We're a free market economy, right? So, we have an aversion to paying for taxes. We want things to pay for themselves, and if they don't, well, then they're free marketed out. They're not the winner of capitalism. But recognize that we always have paid taxes, okay, since the start, all right? Since the start of the United States, remember, like, the Boston Tea Party was all about taxes and taxation without representation, okay? Like, if you want your taxes to be utilized for for something that you find value in, then, like, you've got to go talk about how you want your taxes to be spent. And if you want there to be incentives for change, both on a personal and a corporate, legislative body, then you have to be willing to pay for that. Yeah.
So if we have a money problem, but the government is the one that prints money,
Oh, God.
why can't we just print our own money?
Oh, my God.
No.
Said every kindergartner, that's what I found more money. No, because then the dollar loses value and you're left penniless.
So that's inflation. And if everybody uses different money, you don't know how much each person's money is worth. Like, you could say, hey, my $1 bill is worth 10 of yours, and then everybody would hate you. Okay, which is like, yeah, I didn't tell you the story. My kids, so they had a little economy in second grade this year, and my one child did something normal, and my other space child decided he was gonna sell karate lessons, ninjutsu lessons to be specific. And he was gonna charge $5 for him to stand there and tell you to jump up, turn around, and kick your leg
Sweep the
out.
leg.
Yeah, and I was like, sweetie, no. Okay, like, you can't charge people $5 for this, no one's gonna pay for it, like, you're gonna have just a few customers, so like, in the first place. Anyway, so I talked him down to $2, and then he eventually had to charge us $1 for it. Like, no, he wasn't real upset about it, but I was like, yeah, we're selling a bad service. Okay, I just wanna point out, before you answer the last couple questions on your worksheet, that, our current regulatory solutions that deal with gases are on an international level. And that we've tried to use the UN as an organizing body for these types of international agreements to deal with this global problem. And the Kyoto Protocol was in 1997, 187 nations, including the US at the meeting stage, agreed to cut greenhouse gas emissions much below what actually was happening in 1990. And it was the developed nations, 39 of them, that agreed to reduce those greenhouse emissions. 21 of those 37 did it. They were able to reduce their greenhouse emissions, not to the target level, but they actually made significant improvements. Again, the United States was not a participant in the Kyoto Protocol and in those reductions. The Paris Climate Accords met again then in 2015. 184 nations has signed on to do whatever it takes to limit global warming to 2 degrees Celsius. Kind of put us on those lower emission scenarios and outcomes that the IPCC has predicted for us. And we were signatories of this, and we're on track to do that until 2017 when we pulled out. Yeah.
Why is the US?
Why aren't we? Okay? And so look on the first part, 1 second, look on the other side of your worksheet and look at those 2 questions. So answer, why aren't we in this? What is keeping the United States from making change in regards to greenhouse gas emissions and climate change?
Don't write just Trump, think bigger.
I have a,
Yeah.
Government.
So answer those 2 questions super quick. Why is the US not participating? And then why are you not participating?
People are
Money.
well informed.
It all comes down to money and
Money.
industry and
Money, they're not informed. The people in government are.
Okay, go ahead.
I put money,
Mhm.
ignorance,
Mhm.
familiarity, time consuming, lack of demand of change. They're not demanding change.
I'm also gonna say, people are just stubborn out there. They go like,
It's a power play as
That
well.
comes off like familiarity, stubborn.
yeah, they're just stubborn with it. They're like, it doesn't.
But I think that's because of these international things straight comes up to governmental. It's not people, it's the government, which means
Okay.
there's power.
Why
at play
is the
and
US
influence.
not a participant in these international agreements about climate change?
Money.
Okay, money. Why are we concerned about money?
If it could hinder our import, export, our economy in some way based on the status quo.
Right, okay, I don't understand this because I'm like, the long-term consequences in terms of money output for the United States to pay for dealing with climate change dwarfs in comparison, the small problems we would have about making changes today. Like, people are gonna lose out today, but people are gonna die tomorrow, right? In the worst case scenario.
Self-absorbed.
Like, I don't, the money thing is definitely one reason why we have resistance to change, but it makes no sense to me. Caleb.
All right. So I remember when we pulled out, and part of the reasoning behind it, when I was doing the research, I was in my government class.
Yeah.
I was
Oh,
taking my
nice.
government class when we pulled out. And we
Yep.
talked about it a lot.
Yeah, good.
And the consensus that my class came to was that we pulled out due to a certain president,
Mm-hmm.
that we could not boost our economy in the United States while also trying to reduce the costs. He believed that if we tried to reduce this cost, more of our manufacturing would exit the United States and we would lose more jobs.
Okay,
Okay, so has that not happened? Okay, like, so we pulled out so that manufacturing jobs wouldn't leave. Is that what happened? That manufacturing jobs,
they did that.
they left anyway.
They did the Kansas City shuffle, okay?
Right, they left anyway. And they've left in Ohio, okay? Like, there have been several large plants in Ohio that have closed.
You're right.
Like, it hasn't worked,
That's right.
okay? Like, it's a false argument. Willow.
Another thing for us is power.
That's, yeah, power, influence, and negotiation leverage.
Okay, we touched on these things before. We talked about, why don't we respond to climate change? What is keeping us from making changes and taking on the solutions that we know exist for climate change, whether it's scrubbers and carbon storage, or international agreements, or ascribing to renewable energy, or flushing the world's oceans, with antacid. Why don't we do them? Yeah, Kathy?
Can't agree that it's a problem.
Elena?
We haven't seen a personal effect yet, so we don't want to make a change because we haven't seen the problems.
Our culture isn't feeling the impact of a global issue to the degree others are.
It's a cultural problem with social inertia, okay? Once you identify the problem, you can begin to address it. And the solution to global climate change is not gonna be a magic bullet that comes from science. It's not gonna be a magic regulatory scenario or cap and trade on carbon emissions that takes place. It has to start as a cultural change. Okay,
Let's say, combining these two things together, when I was looking at the fourth question on why don't we take responsibility for climate change,
yeah,
when I combine the solutions, why don't we and stuff, when I was just doing some math in my head.
yeah.
If every person in the United States paid $1 extra in taxes a year, and they put all that money toward climate change,
Yeah.
we could make a huge difference.
Yeah, that'd be $330 million.
It's $1.
I would give $2 for every person in my family, maybe even 20.
I'm
Okay?
kind of at the point where it's like, I would pay more taxes
Yeah.
if this is where the money, if I knew where the money was going to something like
Good.
this.
You have to participate in the system to make change. Okay, you have to participate in the system to make change. That means you gotta pay taxes, and then you gotta hold people accountable for how they use your
I wish I could donate money to a specific thing. Like, I'm gonna give the government money for this.
Oh, yeah, I know, like, when we do your tax return, like, do you wanna give an extra $1 to the presidential reelection fund? And I'm like,
No.
well, right now, no, but I've marked that yes. Right, like, okay, like, if I can say, where do you want your tax dollars to go? Well, like, I want to, I would have some choices I would make. It's kind of exciting. Maybe that would be a system change you can make. Okay, this is the first time in the United States, even though this is 2015 data, that we have been, as a majority of the public, very concerned about climate change. Very concerned about the impact of climate change. Willing to elect candidates that acknowledge climate change is real and that ascribe it to a human cause. Okay, contrary to 2016 and 2015, we thought that. So we are at a point of change. We are going to talk about politics and science in class on Thursday. Okay, that is where our discussion is leading us, is that how do we enact and enforce these types of changes? And can the political system help us or hinder us in this? And what is the role of science in politics? Okay, I would love to have your worksheets. Thank you for staying today. Please remember homeworks are due today. It is also course evaluation week, okay? All the course evaluations are online on Blackboard this semester. Like if you go to your login for Blackboard, it will give you the option to do course evaluations for all your classes. Please do one for this class.